Hello, I'll make a quick overview of the differential protection menu. These two elements we call linkers. They are used to visualize differential and restraint currents from the comtrade file. This one on the top is used when each phase has its own differential and restraint currents. The 3diff 1bias linker is used in cases when all three phases have only one restraint current. This submenu has three options used with ABB relays. pdiff can be used to enter and visualize settings from line transformer, generator or motor differential protections. ppdiff is used with busbar differential protection. With the RET670 calculator, you can emulate the differential algorithm for a 3-winded transformer. These elements are used with corresponding Siemens relays. Let's go to the comtrade page. The first example is with a 7SD522 relay that protects a 330 kV transmission line. We have a phase B to ground short circuit here. Here are 3 differential currents and 3 restraint currents, so I have to use the 3diff 3bias linker. Let's go to the protection page. I'll insert relay settings. Now I need to link analog channels from the comtrade file to the linker. Done. So these dots represent corresponding phases coded with color. The next example is with 7UT613 relay. It protects the part of the busbar at the autotransformer low voltage winding. It's a 3-phase short circuit with huge CT saturation. Here we also have 3 differential currents and 3 restraint currents. Now let's insert the device settings and link the channels. At this time the ID didn't work correctly because of saturation. Let's look at the vector diagram. I'll add phase A. This is an external fault. The next one will be RED670. It's a phase A to ground short circuit with unsuccessful reclosing. There are 2 breakers. Here is the sum of them. We can see differential currents, but they are alternating. There's 1 restraint current. In my opinion, the disturbance recording in the IED is not correctly configured because there should be 3 restraint currents. But let's use this as an example of one feature of our linkers. They can also be used with these alternating instantaneous values. If any link channel is alternating, the linker calculates the signal magnitude and uses it. The only issue is the device look into the past or to the left of the cursor, but all our algorithms look to the right of the cursor. The next example is with REB670 that protects a 110 kV bus bar. We have a lot of lines, two sections A and B, and we see only currents from phase B. Other phases are protected by their own devices. Let's insert settings. I link differential and restrain currents from section A to phase A currents in the linker and from section B to the phase B on the linker. The next example is with RET670. The device protects a 3-winding transformer with a 35 kV high voltage winding and two 6 kV windings. The IED didn't work correctly, it was an external fault. I'll add phase B to the vector diagram. Here are 3 differential currents and 1 restraint current, so I have to use the 3diff 1-bias linker. The settings are too sensitive. Let's try our calculator. I'm choosing matrices. Zero sequence reduction was off. Now I'm inserting rated voltages. I need to link all currents from all windings. So the result differs a little. First of all, as I said earlier, the IED looks into the past, but we look to the right from the cursor, like in the future. Secondly, the IED has something like memory in the restraint current. Now we can't emulate that. Our calculator has one useful feature: you can invert currents in any winding. This may be useful if CTs were not correctly connected. Thank you for watching, peace for everyone.